Yes, ma'am, she is there. Rajeshwari Kasturi.
Shashikala ma'am, can you make her? I am unable to do it.
I could not see her.
No, madam, she is there. Rajeshwari
there,
Kasturi, she is there. It's on mute, madam, and they could not able to unmute themselves, I guess.
Okay, I'll do it.
Yeah.
Yeah, meanwhile, shall we call to her name? It is blocked, I think. Some number has come. So we need to ask Hari. Otherwise, meanwhile, we'll ask another one, next person to present the oral. Okay, ma'am?
No, Rajeshwari is
We'll
there,
solve
right?
this
I can see her message.
He is there, but
Why don't you unmute?
she is
will
there,
start,
but
right?
yeah. Here,
because this
we
problem
could
will
not,
be there for this every participant.
No. So only to her that number has come. I don't know why.
Yeah, the next participant.
Everyone.
Yeah, the next participant is Venkatesan.
Yeah, that's what we are giving that same.
In the settings, you allow everyone.
Yes, ma'am. We'll do it, ma'am. Madam.
Option.
Rajeshwari ma'am, try to unmute yourself. Already that option is there.
Rajeshwari, by yourself, you try to unmute.
Unmute yourself, ma'am. Rajeshwari ma'am.
Yeah, I think it is Rajeshwari.
Now she is a co-host, so she can do, I guess. Rajeshwari, madam, please try to respond.
Yeah, that is what problem is there from her. We will take her again. So just go with the next participant, ma'am.
Yeah, the next participant is Venkatesan, and even he's also not there, I guess.
Really? Okay, so then call another one. So if they come, we will allow them.
The next participant is Purvesha.
Yes, ma'am.
Yeah.
Can you hear my voice?
Yes, sir.
Okay. Can I share my presentation?
Yes.
But presentation could not see the presentation. Okay. What happened?
Hello, sir. We could not able to hear your voice.
Hello.
Yes, hello, sir.
Okay.
Yeah.
I select the research topic, for the nanotechnology, because the nanotechnology have a wide application in the chemistry as well as the medicinal chemistry, biomedical chemistry, healthcare, and biological, in terms of the gene delivery, biotechnology, physics, etc. There is so much application of the nanotechnology. In various fields, the novel compounds are produced by using the nanoparticles, and number of the research work are carried out for the formation of the metal containing nanoparticles, like the metals like the nickel, copper, silver, gold, etc. But the very few research work are carried out in the preparation of the organic nanoparticle. Therefore, I select to prepare the organic nanoparticle containing heterocyclic compounds. The heterocyclic compounds are nitrogen containing and oxygen containing heterocyclic compounds are also contains the pharmaceutical as well as the biological importance. And therefore, I thought to prepare some nanoparticles which contains the oxygen and nitrogen containing heterocyclic compounds. And for this, we synthesize the oxidizole containing nanoparticles, means the novel heterocyclic compounds which contains the oxidizole movity. And for characterization, we use the following parameters for the carbon, hydrogen, nitrogen analysis. Melting point also we determine IR spectroscopy and NMR spectroscopy, UV absorption spectroscopy, and the nanoparticles which observed by our scanning electron microscope, means SEM. The whole research work I summarize in this chart. We first prepare our starting material, which is synthesized from the naphthothioazole with the sulfonyl chloride, and we get the compound number 1. And this compound number 1 is treated with the ethyl acetoacetate, and we get the ethyl acetoacetate type of the movity. And this movity is combined with the hydrazine hydride, and we get the hydrazine type of the movity. And this hydrazine hydride is further treated with our benzaldehyde in presence of the iodine or air, means it is our green chemistry type of the reaction, and we obtain the final our compound which contains the oxidizole movity. Okay, and this is the characterization. This is the characterization peak I observed for our synthesized compounds. And finally, we prepare our nanoparticle which contains our synthesized targeted compound. The organic nanoparticle is prepared by the reprecipitation method. The nanoparticles of the anti-OD was synthesized by dissolve this anti-OD in THF solvent, and then we quickly injected 100 microliter of the anti-OD THF solution into 10 ml of the foil solvent. What is a foil solvent? Which is a deionized water, and on the inert atmosphere, which requires stirring at room temperature, and we obtain the nanoparticles. And the nanoparticle solution have a color of pale yellow color. And this nanoparticle is characterized by our SEM. And the SEM image of anti-OD nanoparticle contains the spherical rod-like shape, and the average size is 18 nanometer. And the electronic microscope image of the organic nanocrystal was not apparently due to very low concentrate of the organic nanoparticle. This nanoparticle is stable in the solution at the direct medium, means direct room, without the precipitation for 2 days. 2 weeks. This image is validated by the preparation of the anti-OD nanoparticles via reprecipitation method, and anti-OD nanoparticle held together by pi steric effect.
Sir, it's a time reminder.
Okay, and then we conclude, and finally we conclude that a novel heterocyclic compounds containing anti-OD was designed and they synthesized in our laboratory, and we prepared the nanoparticle containing heterocyclic compound. The optical property of the aggregation of the nanoparticle is characterized by the SEM, and we obtain the nanoparticles in our compound. In the last object, the medicinal and environmental application will be attempted in future of our synthesized nanoparticles. Okay, thank you.
Thank you, sir.
Thank you.
Yeah. Any questions? Participant can ask a question. Okay, if there is no question, we'll go to the first participant. Kavita Madam and Rajeshwari Madam has joined. She is OP number 17. Oral presentation number 17. Yeah.
Okay. Can I ask one question? Parvesh?
Yeah.
Hello.
Parvesh Shah.
Hello.
Yes, madam.
I have a question. Okay, you just synthesized your particles, but you did not did any application oriented on this, right?
Yes, application is in
That's what I
progress.
understood.
I will check the antimicrobial activity, anti-tuberculosis activity, but it is in progress in our laboratory.
Okay, antimicrobial and anti-tuberculosis.
Yes.
Is there any other reports on these heterocyclic compounds as nanoparticles and which were like approved for drug delivery or any other thing?
No, I did not think about that.
Okay, and one more question is in your presentation, you always better to show some images which shows the nanoparticle size and all, rather than writing the matter. It's always better you show us all the images. Even for the characterization of the compound also, it's better you show us NMR spectra or UV spectra. That will be easy for us.
Okay, next time I will do your apply your suggestion. Okay.
Okay, thank you.
Okay, thank you, madam.
Thank you, Parvesh Shah. And then Rajeshwari Madam, you can go ahead.
Good afternoon, ma'am. Am I audible, ma'am?
Yes, ma'am, you are audible.
Yes, ma'am, you're audible.
Good afternoon, Kavita, ma'am. Shall I share the screen, ma'am?
Good afternoon, Rajeshwari. Yeah, you can.
Shall I start, ma'am?
Yes, to start.
Yeah.
So, my topic is copper metformin ternary complexes, thermal DNA binding, and molecular docking studies.
Rajeshwari Madam, you are in mute. We could not hear anything.
Okay. So, metformin hydrochloride is one of the substituted bigonide, which has good medicinal values and acts like a good anti-diabetic drug. Many of the vanadilyl and platinum complexes of metformin shows insulin activity and anti-tumor activity. So, based upon this biological significance of metformin and copper metal ion, we plan to synthesize ternary metformin complexes of copper metal ion. And the screen, this PPT is not okay. To say, so main objective of this study is we have to say we are synthesizing ternary metformin complexes of metformin using different secondary ligands like OFN, OPDA, and bipyridine. So mainly we have studied characterization of these complexes by using IR, LCMS, TGA, elemental analysis, magnetic susceptibility, and electronic spectroscopy, and DNA interaction studies, both absorption and emission studies. So we have synthesized the complexes by dissolving metformin in KOH, and we have added this to the metal salts, and we kept it on water bath. And to this, we have added secondary ligand, and the colored complex is separated out. The characterization of metal complexes. The analytical and physical properties of the complexes are studied. So mainly LCMS through the molecular ion peak, consistent molecular ion peak we got from the LCMS spectra. And from the elemental analysis, we have concluded the empirical formula and it shows 1:2:1 ratio of metformin auxiliary ligand and the metal ion, and maximum molar conductance values recorded for these complexes shows that they are electrolytic behavior, and the chloride presence of chloride ion outside the coordination sphere. So the thermal analysis, we have conducted thermal analysis. So stepwise the composition of thermal decomposition of the complexes is recorded up to 1000 degrees centigrade, and from the thermal analysis we conclude composition of the complex is confirmed. So from this, from one of the step of thermal decomposition, we have calculated kinetic and thermodynamic parameters, and from this we conclude that these complexes are spontaneous and they are thermally stable. Magnetic and electronic spectra of the complexes. So from the magnetic susceptibility values, magnetic moment values are calculated, and octahedral geometry is confirmed, and the geometry is further confirmed by the electronic spectral measurements. So these are by the position and number of DD transition bands. So which are these transition bands which appeared for these complexes in the electronic spectra are the characteristic of octahedral geometry of copper complexes. So from this we conclude octahedral geometry to this, and from the IR analysis the stretching frequencies of metformin and auxiliary ligands are shifted on complex formation, and a new stretching band is appeared in the complex which shows presence of ring. So from this we conclude that,
ma'am, time reminder please.
Okay. So from this we conclude that metformin and the ligands coordinate to the metal through neutral nitrogen donors. So from the ESR analysis we conclude the metal ion environment, that is octahedral geometry, and the metal to ligand bond covalency is also confirmed, and mainly out of plane pi bonding is seen. And the DNA interaction studies we have done by using absorption, emission and quenching studies. And from the UV absorption studies, groove mode of binding is confirmed, which shows increase in absorption intensity is recorded, while titration, that is hyperchromic shift, is seen. And this groove binding is further confirmed by the viscosity studies. Slow increase in the relative viscosity of the solution is recorded, which confirms groove mode of binding. And from the emission and quenching studies, we conclude that metal complexes interacts with the DNA. So, and
Ma'am, we have to stop this.
Okay.
Yeah. If anything you want to conclude, you can conclude.
So from the binding studies, we conclude that the complexes interacts with DNA through groove binding, and this is further confirmed by the viscosity measurements, and from the docking interactions also. So more docking score is seen for complex 3. That's it. Thank you, ma'am.
Yeah, the participants can ask a question.
Kavita ma'am, any questions?
Yeah, Rajeshwari?
Yes, ma'am.
The binding constant which of your compound with DNA is around 10 to the power of 4. I have seen it.
Yes, ma'am.
But this is a kind of weak binding.
Yes, ma'am.
Actually, to do any biological studies or, better drugs, always you should have more than 10 to the power of 5 at least. Up to 10 to the power of 8. So you can try a ligand, or you can change the donor atoms on the ligand, so that it is going to increase the binding efficiency. Then you can use it in for further study.
Okay, I will try, ma'am. For further complexes, I will change the secondary ligands. I will try for.
Okay, good.
Okay, thank you, ma'am.
If there is no question, thank you, Rajeshwari madam.
Thank you, madam.
Yeah. And a kind notice for all the participants, whenever I say time reminder, it means that you have 1 minute left for your presentation to finish. Right. So we would like to go for the next participants. Venkateshan, is he there? Okay. So the next one, we have finished 19. We'll go to the 20. Richa Arora, Kalash Gupta.
Are we audible, ma'am?
Yes, ma. There is a disturbance from your side, Kalash. Can you please ask others to mute themselves? No, sorry, stop talking, so that your presentation can be properly, we can hear.
Can we start?
Yes, ma.
Okay. So, good afternoon, everyone. I am Priyal from BSc Chemistry 3rd year. And I am Kalash Gupta from BSc Life Sciences 3rd year, Shivaji College, Delhi University. Today, we are going to present an interdisciplinary project under DBT Star College scheme performed by students of BSc Chemistry, Botany, and Life Sciences Department under the supervision of Dr. Richa Arora, Dr. Ashwani Sharma, and Dr. Nandgopal Giri. The title of our project is Effect of Soil pH on Germination and Growth of Triticum aestivum and Ziamis. The various environmental stresses such as extreme temperature, problem soil, include soil salinity, have affected the production and cultivation of agriculture crop. The pH of soil is mainly a measure of alkalinity and acidity of the soil. For successful plant growth, pH should be in between 5 and 6.5. pH always affects the growth and germination of the plant and the texture of the soil. This study basically aims to investigate the effect of initial pH level of soil on the seedling and determining the optimal pH and for germination of seedling growth in the NCR region. We have chosen maize and wheat seeds for our study, and the problem soil was collected from a piece of barren land of Sonipat. Field was divided into different homogeneous units from taking soil samples and with removal of rocks, dried leaves, etc. Soil was collected from depth around 6 centimeter below the surface of soil. It was packed and labeled. Soil was sieved, grinded, left in tub for a few days, and then added to beaker with distilled water and left undisturbed till soil gets settled at bottom. Also, solution of aluminium sulfate and calcium hydroxide was prepared and added. We prepared the pots for the sowing of seed in various soil samples with different solution of different pH prepared earlier. The range was 4.295 to 12.424. The pH of problem soil is nearly 4.0, and the pots were labeled and they were placed where they get the adequate amount of sunlight and the water daily. Growth was monitored and the shoot length was measured from time to time, and the average value was recorded. We observed there is no germination in acidic soil sample, but as we increase the pH, the germination increases and the maximum length was at 12.424 pH. Let's move to the data analysis using Excel for wheat in terms of area production and yield across India over span of 10 years, that is from 2008 to 2018. Here on the screen, you can see 4 graphs. It is analysis of wheat only. In second graph, area versus year, in span of 10 years, there is no steep increase in the area available for wheat in million hectares. In the third graph, production of wheat in span of 10 years, there has been subsequent but not very regular increase in production in million hectares. We further sowed the seed of wheat and maize in 3 sets of soil: problem soil, neutral soil, and the basic soil in crates, so as to increase the ground area in order to use result obtained in actual field, as we have already attached the picture of sowing and the growth of seedling in the crates. Now on the screen you can see we found the length of various seedlings of wheat and maize grown under different pH range was observed. On analyzing growth of seeds, still no germination was seen in acidic medium, whereas in basic soil again witnessed maximum growth from both wheat and maize. Now, coming to the conclusion, we can say there is no germination in acidic soil of the pH 4 and the maximum length comes out in the alkaline medium. at the pH 12.4 to 4, because in this pH range, availability of nutrients was the highest. Also, the single parameter is not enough to determine productivity of the wheat. Thank you so much for patiently listening to us.
Thank you, Kalash. And the session is open for questions. Kavita ma'am?
Yeah, it's a nice presentation. Like definitely for the BSc students.
Yeah.
Yes, ma'am.
Who are learning things. Very good.
Thank you, ma'am. Thank you, ma'am.
Okay. And from the conveners of the workshop, and we received just now we received a note from the conveners saying that the oral presentation are strictly confined to the research scholars and the research supervisors can present, not the PG and degree students. Okay. Yeah. Kalash, anyway, it's very nice presentation. Wish you all the best. And now let's go to the next participant. Amruta Kohli, Lavanya, SP Lavanya. Mom, Revati mom, she is not there, no?
Lavanya is not there. So
Yeah.
next one,
Excuse me,
22.
Yes.
Ma'am, this work has been done under our teacher only, that is a professor. So we just presented our project here.
Yeah, we know, ma, that's what we are saying it. And if the work is done by you, even under the presence of a supervisor, we are asking them to present it because it is for research scholars and the researchers of the department. Okay.
Okay, ma'am. Thank you, ma'am.
Yeah.
Next is OP22, Amrita Kohli.
Shall I share my presentation, ma'am?
Yeah, sure.
Good afternoon, ma'am. I am Ms. Amrita Kohli. I am presented on a porous activated carbon derived from agro-waste sugarcane pith for enhanced CO2 capture and methyl orange dye adsorption performance. When we think the environmental pollution, it typically comes in different types. Here we explore air and water pollution. In this work, we are focused on CO2 capture and methyl orange dye adsorption because carbon dioxide is a major greenhouse gas which is present in the atmosphere, which is the bigger contributor to the global warming. And similarly, reactive azo dyes are widely used for the dyeing process because of their low cost. The accumulation of carbon dioxide and methyl orange dye in the environment aspects mainly responsible for the pollution of these aspects, which causes server environmental problems. For reduction of these issues, different adsorbents are used, such as MOPs, silicas, COFs, zeolites, activated carbons. Among these, activated carbons are widely used adsorbents for the because of their low cost, easy availability and easy preparative methods. But still there are numerous problems for the preparation of activated carbons due to the limited precursors with the largest price and for the large applications. We are selected natural resources, that is the agro waste, which are easily available, low cost, and they are easily decorate. It also possesses high chemical, thermal and chemical stabilities and the wide availability. So we are focused on a sugarcane waste pith as a adsorbent. So we are developed the activated carbon from sugarcane pith waste for in 2 steps. In first step, we are it is synthesized by chemical carbonization using H2SO4 as a carbonizing agent within ratio 1:2 weight by volume. Then the formed product is termed as a raw carbon, with, that is RC. Then this RC is physically activated under the inert atmosphere and the activated carbon is formed. This obtained adsorbent activated carbon is further characterized by using different characterization techniques, that is XRD, FTIR, FESEM, BET, PSD plot, and XPS. Here the powder X-ray diffraction pattern shows typically 2 peaks at 23 degree and 44 degree corresponding to 002 and 101 plane. After N2 activation, the AC shows 40 corresponding 44 degree peak, which shows the graphitization of carbon atoms at some extent with the stacking like structure. Here is the FTIR spectrum, which shows the some functional groups like OH and acidic functional group. These acidic functional groups are mainly responsible for the enhancement of CO2 capture and methyl orange dye adsorption. Here are the FESEM images. The FESEM.
It's a time reminder.
FESEM image and morphology of the AC and RC. This is the BT plot and PSD. Here we get the 299 meter square per gram area for RC material, and it is improved 3 times after N2 activation. It is 725 meter square per gram with the micropores and mesopores. This is the XPS, which typically shows C1s, oxygen 1s, and nitrogen 1s. In this characterization, we are got a higher nitrogen content in a AC. So the characterizing material further applied for the CO2 capture and methyl orange dye adsorption. CO2 capture is carried out at 3 different temperature, 288 Kelvin, 298 Kelvin, and 30 Kelvin. These are the results.
Amrita, time is over. Yeah, you conclude.
This is our conclusion. We get micro and mesoporous ordered structure, which shows the, here AC shows the higher 2.71 millimole per gram CO2 adsorption and 527 meter per gram dye adsorption, and it acts as a good adsorbent. Thank you, ma'am.
Thank you, Amrita. It's open for questions. Anyone would like to ask a question?
Yeah, Amrita, may I ask one question?
Yes, ma'am.
Yeah, as you said that it is after calcination and activation, you have got microporous and mesoporous carbon.
Yes, ma'am.
But with the nitrogen adsorption studies, the hysteresis loop, which is that you have shown in the slide, so that is not corresponding to the mesoporous material.
Yeah, ma'am. It is in case of AC. In case of AC, that is after N2 activation, it shows a smaller hysteresis H4 type. So, only AC is a contains micro and mesopores, and therefore it is a good adsorbent.
That is also
for the CO2 capture and.
That is also not in the mesoporous range. And also, though the carbon is with a very high surface area, this carbon materials, because of the and what is that? There's a distinction and the chemical nature. These carbons are practically they are not advised for these. Just raw carbon, only the active carbon is not advised for the the CO2 absorption materials. And what is I think you have studied this absorption. How much the CO2 is absorbed on this?
For AC, it is 2.71 millimole per gram.
How many hours you did it?
2.72 millimole per gram for AC. For active.
Time. How many hours? Time on stream. Have you studied the time on
How
stream?
much time?
Time on stream studies.
For absorption, Amruta, how much time you have kept for the absorption? She is asking, Madam is asking about time. Time constraint for the absorption to study. How many hours or minutes, whatever, what is the time limit?
Sorry.
Okay. Yeah, okay, fine. Good luck. So nice work you did.
Amrita, I have a suggestion.
Okay.
Whenever you are having time bound things, like within 5 minutes you need to present, in that case you always better skip the introduction, don't need to show so much of introduction. It's always you discuss results and discussions more. Okay,
I will take care
so that you can be within the time. Yeah, it's
Amrita,
a nice presentation. Thank you.
Yeah, yes, ma'am. It was really nice, and you have done a lot of work. There is a lot of data to show. So better, as Madam said, whenever there is a time bound, better you concentrate more on the results rather than introduction. Yeah.
Yes.
Thank you, Amrita. All the best.
Thank you.
So the next participant, it is Sunila Kumari.
Hello, Madam.
Hello, Madam.
Good afternoon, Madam.
Yeah. Good afternoon, Kavita, Madam. How are you, Madam?
I'm good. I'm good.
It's nice to meet after a long time to this seminar, Madam.
Yes, Madam.
I'm Dr. Sunila, Assistant Professor in Department of Zoology, University College for Women, Koti, Hyderabad. I am presenting today on Ascaridia galli, chicken nematode, as a source for nanoparticle and nanofiber. So the abstract of my topic, today's topic is the reports have suggested that there are drastic side effects about the use of metallic nanoparticles in biology and medicine. So it's more relevant to explore and identify more natural and bio-friendly and also effective alternatives to these metallic nanoparticles. So for the first time in the present study, we have attempted to synthesize nanoparticle and nanofiber from an unusual material, that is intestinal nematode of the chicken, which is Ascaridia galli. So this parasite, it measures about 30 to 80 mm in length, and this was removed from the chicken intestines and processed to prepare nanoparticle and nanofiber. Nanoparticles were synthesized using the method of acid hydrolysis, and nanofiber was prepared using electrospinning technique. And the size of the nanofiber was 6 centimeter into 3 centimeter in size that we got, and scanning electron microscope images of this nanoparticle was 48.46 nm to 20 μm, and nanofiber was 88 nm to 2 μm, which was matching to the average standard size of the nanoparticle and nanofiber. And today we are going to talk about relating the parasitic nematode parasites, which are collected from the chicken intestines to prepare the nanoparticle and nanofiber. So these nematodes, they come under invertebrate phylum. So I in this I'm not concentrating more about the chemistry of preparation of nanoparticle, but I am giving an idea that from an invertebrate round, which is a roundworm, we can, which is considered as a waste, we can prepare nanoparticle and nanofiber from these worms. So on the left side of the screen, you can see the student cutting open the chicken intestine, and on the right side, you can see in the Petri dishes 3 Ascaridia galli nematode worms that are collected in the Petri dish, and these worms are pulled up and processed for preparation of the nanofiber. The unique versatility of nanoparticles is attributed to their size and dimensions, and it is interesting to note that these materials exhibit certain unique physical properties when they are downsized to nano proportions, in contrast to the heavier material which show constant physical properties. The main driving force for the development of nanotechnology stems from the understanding of biological processes, as they are often happening at a nanoscale, and living cells are typically just small in size. The intestines, which are infested with the parasitic infection, that is the nematode Ascaridia galli, were collected carefully into the Petri dishes, and these worms are greenish white in color. They are very small, 70 to 80 mm in length, and after collecting, they were dried overnight in an incubator at 37 degrees Celsius, and these worms, after thoroughly being dried, they were pounded into fine powder using the mortar and pestle, and
it's a time reminder,
processed for the synthesis of the nanoparticle and nanofiber. So these are the results, the SEM or the images of the nanoparticle and nanofiber that are prepared from the nematode parasite. So you can see the nanofiber, which is of the diameter 88 nm to 2 mm, and you can also see the nanoparticle, which is of diameter 48.46 nm to 20 mm. So successfully we could synthesize the nanofiber and nanoparticle from these nematode parasites. So nematode particle, it is based on drug delivery system, and for most importantly in medical treatments, in transplantations and cancer treatments, we use the nanoparticle, and metallic nanoparticles are being used now. So we hypothesize to use more biologically compatible materials in the place of these metallic nanoparticles that are being used. So nanofibers are more frequently used in tissue engineering, bone remodeling, and skin regeneration. And it is often advisable and advantageous to use nano structures which are derived from the natural components for the medical applications. Bio nanoparticles.
Ma'am, it's finished, ma'am.
They are parasites which are eco-friendly, cost-effective, and also biocompatible. That's what we propose at the end, that these parasites are eco-friendly, cost-effective, and more biocompatible. Thank you. If there are any questions.
It's not a question, ma'am, just Sunila, ma'am.
Yes,
it's an interesting topic, ma'am. And may I know what is that metal that you have nanoparticles that you have prepared? What is that metal?
I'm not able to hear you, ma'am. Sound is too low.
The metal nanoparticles you have prepared, right? Fibers and nanoparticles. And which metal? What is that metal?
We are not using any metal.
Madam, no metal. No metal. That's what they are saying.
Parasitic particle from the nematode. We have dried this nematode, and through polyvinyl alcohol we have added and prepared nanoparticle and nanofiber completely from the parasite. No metal was used.
Yeah, that is. Oh, yes, ma'am. Yeah, it's interesting, but nice, ma'am. So,
Sunila, ma'am.
Yes, madam.
nice presentation. And is there any reports of these biological nano particles, they were successfully utilized in drug delivery?
Yes, ma'am. Usually plant material.
Yeah, plants I have heard.
But
and one more thing.
Refer to some
what is the availability of the madam?
Bacteria and fungi
Continue,
are
madam.
also being used nowadays. Bacterial collagen has been successfully used. From bacterial collagen, nanoparticles and nanofibers have been successfully prepared, and they are being used for the medical use. And this is a bio-waste material. From the chicken intestines are not useful; they are thrown, as you know. From the chicken intestines, we have collected these bombs. So we just wanted to prepare something best out of the waste.
Okay, good, madam. But my question is, like, how much material we need to collect to get how much is the quantity of the nanomaterial we are going to get, because that is also that quantification is also very important. Yes. And how much time, our time, and all this.
1 gram we have pulled up the parasites. For about 100 parasites we had to pull up to prepare a nanoparticle.
How many chicken intestines we require to pull up 100 parasites?
It depends, madam. Depends on the infectivity. Sometimes in 2 intestines only we can collect 100 parasites. Sometimes if the infection is less, we can have to go for more number of intestines. From 2 intestines we can pull up.
They won't cause harm to
yes, in human cells. I want to tell you, this is a chicken nematode, Ascaridia galli. They do not harm humans. In humans, we have a different roundworm, Ascaris lumbricoides, which is similar to that of Ascaridia galli. But Ascaridia galli infects Gallus gallus, the chicken intestine only. It cannot infect humans.
Okay, thank you, ma'am.
Thank you so much, ma'am, for giving this opportunity. I have applied for a DST project regarding this. So I was enthusiastic to share this with all of you. Thank you.
Thank you so much.
Thank you.
Yeah. Thank you so much, ma'am. It's a really very nice and innovative idea, actually. And the same question I have, and whether this organism which you are handling, whether it will infect the humans or not. But the end, you have answered the question, ma'am. And yes, wish you all the best for the project, ma'am. Yeah.
Thank you. Thank you so much.
The next participant, it's Hemalata. S. Hemalata.
Yes, ma'am. I'm here.
Yes. Go ahead, ma'am.
Yes, ma'am. Is it audible, ma'am?
Yes, ma'am.
Okay. Good afternoon, one and all. I'm Hemlata. I'm going to give oral presentation on in silico ADME prediction, synthesis, and biological evaluation of nitrogen-containing heterocyclic compounds. So these are the various contents of my topic. And here, the abstract, the main one is, here I'm going to prepare the imidazole-based chalcone derivatives. So here, the imidazole with the reaction with acetyl chloride, it will give N-acetyl imidazole, and reaction with the different aromatic and aliphatic.
Madam, voice is very low.
Okay, ma'am. So here, first I am preparing the acetyl imidazole with the help of acetyl chloride. And then again, the second step, these acetyl imidazole going to react with the different aromatic aldehydes in presence of alcohol and base. So all the synthesized compounds were confounded with the help of physicochemical parameters and spectral analysis with the help of NMR, IR, and mass. All the synthesized compounds were predicted using various free software tools, Mole Inspiration, MoleSoft, and O-Series. The main purpose of doing this online free tools to calculate the bioavailability and oral absorption. Then biological activity, we did antibacterial, antifungal, and antioxidant activity. So this is based on the literature review. We have conducted this experiment, ma'am. So there are a number of marketed products are available based on this imidazole ring. Example is clonidine and albendazole, metronidazole. All these few compounds are containing imidazole ring. And this is a scheme, ma'am. So imidazole react with the acetyl chloride. We are able to get N-acetyl imidazole. This N-acetyl imidazole react with the different aromatic and aliphatic aldehydes in presence of alcohol and base. We are going to get the imidazole based chalcones. So we did these 8 derivatives for this, and we went for IR, NMR, and mass of different derivatives, ma'am. So here the first one is N-acetyl imidazole. We did NMR, IR, and mass. I am representing to only here the NMR part. And next one is various derivatives we have seen. So here I am representing only one derivative, that is trimethoxy derivative of imidazole based charcoal. So we did all IR, NMR, and mass for all the 8 derivatives. So we are confirming the structure. So pre-available software tools, mole inspiration, O series, and the remaining other tools, we can calculate the bioavailability and oral absorption. So whatever the synthesized compounds we did, they are all following the Lipinski rule of 5. That is, hydrogen bond donors should be less than 5 and acceptors should be less than 10 and molecular weight should be less than 500. So all the synthesized compounds are following Lipinski rule of 5, madam. So these are better available, we can use for the oral absorption purpose. It will give the good permeability and pharmacokinetic and pharmacodynamic properties. These are the various tools. And we did antibacterial and antifungal and antioxidant activity. So here for antibacterial activity, we have selected gram-positive bacteria and gram-negative bacteria. And ofloxacin is the standard antibiotic we have selected. So we prepared various concentrations. The drug, the derivative which is having the nitro group is having the better antibacterial activity. We have followed with the help of couplet method. And next one is antifungal activity. So here we have taken the standard drug Rhiziofulvin. So we have used the organism is Penicillium creoscinum. So the derivative of methoxy group and the derivative of trimethoxy derivatives have showing the better antifungal activity. And next we did antioxidant activity. So all the activities we did in our laboratory only, ma'am. So this for antioxidant activity, we have followed the DPPH method. The standard drug we have taken ascorbic acid. So IC50 value is...
Hemlata madam, it's a time reminder.
Okay, ma'am. So all the drugs, few drugs are showed better antioxidant activity. So the conclusion, so all the imidazole based chalcone derivatives, we have synthesized 8 derivatives. So they are characterized with the help of NMR, IR, and mass spectroscopy for all the 8 derivatives. So we have calculated the molecular properties prediction by using 3 software tools, mole inspiration, mole soft, and O series. So all the compounds we have synthesized, they are following Lipinski rule of 5, obeying the Lipinski rule of 5. That means it will having the good bioavailability and good oral absorption. So antibacterial, antifungal, antioxidant activity also we did. The derivatives which are having the pyrrole and methoxy derivatives, they are showing the better activity. So these are the various references we did. Thank you, ma'am.
Thank you, Hemlata ma'am. Any questions? Okay. If there is no question, we will go for the next participant. Thank you, Hemlata ma'am.
Thank you, ma'am.
Yeah.
Ma'am, thank you, Hemlata ma'am. When you are comparing your drug activity, either bacterial or fungal activity, with what you are comparing?
So we are comparing. Suppose if you are taking the antibacterial activity, ma'am. So we are couplet method we are following, madam. We are calculating.
No, I'm not asking what method you have followed. When you compare with a drug, with a standard drug,
Yes, ma'am.
like which is available on the market.
Yes, ma'am.
How good your results are when compared to a market which is already available in the, which is the drug which is already available in the market.
So it is showing the little means equivalent potent to the standard drug, ma'am.
No, the top one is the concentrations which you have used.
Yes, ma'am. We have prepared 50, 70.
And did you mention anywhere the standard drug?
Yes, ma'am. Here we have mentioned, madam. For antifungal drug, I have mentioned here griseofulvin, ma'am. For antibacterial, we have mentioned the ofloxacin. For antioxidant, we have mentioned.
Griseofulvin. Okay,
Yes.
okay.
For antioxidant, we have taken ascorbitas.
Okay, okay.
Thank you, ma'am.
Okay, thank you.
Okay, we'll go to the next participant, and is OP number 25, Vinayak V. Gawadi.
Okay. May I share the screen?
Yes, sir.
Is it visible?
Yes, sir.
Okay. Good afternoon to all of you. Myself, Vinayak Gawade, working under the guidance of Professor K.M. Garadkar, Department of Chemistry, Shivaji University, Kolhapur. I'm presenting my research work entitled Plant Mediated Synthesis of SNO2 Nanostructures for Methyl Orange Degradation. So particularly, I'm focusing on photocatalysis application. So we just, I'm just going in few. What is SNO2 photocatalyst? It is an N-type semiconductor material which is also known as tannic oxide. Its mineral form is called as cassiterite. It is one of the main ore of protein. It crystallizes with the tetragonal rutile structure, and the figure 1 shows rutile structure of SNO2. And for this work, I have chosen Syzygium cumini leaf extract for the biological transformation of SNO2. I'm just going with some of the parts of Syzygium cumini. It comes under Myrtaceae family with genus Syzygium and species cumini. Then, what is the reason of choosing Syzygium cumini plant for biotransformation? Because it contains a large number of phytochemicals like gallic acid, ellagic acid, ferulic acids, synaptic acids, which can serve as good reducing and stabilizing agents. And due to the richness of phytochemicals, the plant is a well suited candidate for the synthesis of SNO2. So this is scheme 1 shows schematic representation of synthesis of SNO2 nanostructures, where leaf extract of Syzygium cumini is added in essential for solution at 60 degrees Celsius, stirred for a few hours. Then we got yellowish gelatinous precipitate, which on further washing and drying, and after calcination 400, we got SNO2 nanostructures. Figure 2 shows plausible reaction mechanism of SNO2 synthesis, where phytochemicals from Syzygium cumini plant can interact with SN plus 4 ion of SnCl4, which so further formation of bridge-like network, which on decomposition at 400 degrees Celsius, SnO2 nanostructure formation is takes place. So this is a plausible mechanism. Figure 3 shows excited patterns of SnO2 nanostructures. We have compared the excited pattern with the Jessipedes card number 770452, which completely matches with this. The escalated pattern shows tetragonal structure with average crystallite size of 3.26 nanometers. Figure 4 shows UV visible DR spectrum of SNO2, where inside shows a tau plot, alpha SNO square versus energy plot, where exact band gap of material is determined, which is 3.59 electron volts. Figure 4b shows FTR spectrum of synthesized SNO2, where SNO-SN bond formation is confirmed with the between the range of 500 to 600 nanometers, confirms SNO2 formation. Figure 5 shows effusive images of SNO2. It shows little aggregation with spherical morphology. And figure 6 shows 10 images of SNO2, where figure 6A, B are PM images. Figure C is HR10 images with which is showing d-spacing of 0.33 nanometer, which is comparable to 101 plane of XRD, showing tetragonal geometry, which is confirmed by XRD. And figure 6D shows SID pattern, which confirms polycrystalline nature of synthesized SNO2 nanomaterial. Further, BET analysis was carried out for N2 absorption disruption studies. It shows type 4 absorption isotherm having surface area 58.43 meters square per gram with a pore diameter of 3.59, showing mesoporous nature of synthesized material.
Vinayak sir, you have to conclude.
Okay. So in the conclusion, we have successfully prepared a UV active SNO2 material having band gap 3.59 electron volt. The method is cost effective, simpler and simpler biogenic method, and a novel green mediator is used for the synthesis of SNO2 and successfully explored for the photocatalytic degradation methyl orange. And 88% degradation efficiency observed within 180 minutes under UV light. And also synthesized material shows excellent reusability for consecutive 5 cycles, 88% to 80%, which is useful for practical application. Thank you.
Thank you, sir. And any questions? Okay.
Kavita ma'am?
Yeah.
No,
Sir,
you can
yeah.
call other one.
Yeah.
Sir?
Yes, yes, ma'am.
May I, it's nice work and nice presentation, sir.
Thank you.
And
Thank you,
you have used only this tin oxide for degradation of this orange, or what is that?
yes,
Methyl orange?
just a tin oxide material for degradation of methyl orange.
Okay. So with the tin oxide itself, you have got 80%.
88% degradation efficiency within 3 hours, 180 minutes.
It is
Under UV
degraded.
light.
What are the products that you have got after the degradation?
Actually, CO2 and H2 formation is there. So we have sent sample for MS analysis to confirm whether these are the only products or something else is there.
Your main aim is just degradation of this one.
Just degradation. Up to this, just degradation.
Okay, fine. Thank you.
Thank you, ma'am.
Thank you, sir.
Thank you, ma'am.
Yeah, next oral presentation, Aparna madam. Why Aparna madam?
Good afternoon, madam.
Good afternoon, ma'am.
Madam, shall I share the screen?
Yes, madam.
Madam, is it visible?
No, ma'am, we can't see your screen.
Yeah, we can only see your screen. Like we can see you. Yeah, now.
Yeah, now it is visible.
Is it visible now, madam?
Yes,
madam.
Yeah.
Yes.
Thank you, madam. Very good afternoon. I am Dr. Y. Aparna from Mathurshri Engineering College, and I have obtained my PhD degree from under the guidance of Professor Sharada madam. She is the retired head of the department of Osmania University. Now, currently, I'm working for Mathurshri Engineering College. My topic is chances and confronts in the utilization of carbon dioxide. So, I'll show you this slide from the beginning. Sharda madam is my guide. And as we know that carbon dioxide is colorless and odorless gas, but at high concentrations, it is slightly acidic in nature. And we all know that the density is around 1.98 kg per meter cube and about 1.53 times more denser than that of air. And these carbon dioxide moieties, whatever carbon dioxide emissions, we know what is the effect, that is greenhouse gas emissions and other anthropogenic carbon dioxide emissions. These carbon dioxide emissions are also on the positive side used as refrigerant, fire extinguishers, and for the inflating life belts we use when we go on steamboats or any places where you want to have a diving in waters, life jackets, plastic bowl, etc. And they're also used in the beverages. These greenhouse gases, almost now we have a sequestration called as carbon business, that is almost giving up $1 trillion per annum, $1 trillion per annum as an estimate given by some survey. So what is our main aim is to achieve carbon net zero, and that is the key challenge for our environment now. That's of global importance. And we are navigating through these climatic conditions with technology, and we have to look upon conditions like the cost, space, execution time, and with minimal on-site disruption. And according to survey, it is observed that there are some firms supporting this CCS. This stands for carbons capture and storage. We have Tata Steel, Cemex, Chevron Technology, Acronym, and Tuticorin. What do? They actually have installed a coal-fired boiler to capture almost 60,000 tons of this carbon per year, and they convert this carbon dioxide to methane and soda ash, hydrogen, and other renewable sources. This is a typical carbon dioxide separation plant near the power plant, like you have the fossil fuel burning power plant, which is attached to a commercial carbon capturing system, and almost it can have the capacity to trap this 800 tons of the carbon dioxide per annum. And this is almost 10 times less than what is emitted from the average fuel point. And it is our, the duty of an industrialist or the person who is dealing with such ventures to capture these by retrofitting the pipelines or the other storage devices. And the various capturing methods of carbon dioxide include post-combustion, pre-combustion, oxy-combustion, and chemical looping combustion. So in the post-combustion, we can see that we have 21% of oxygen and almost 79% of air. And the fuel and air mixture, we have the fossil fuel combustion. And the flue gases which are coming out consists of 3 to 20% of carbon dioxide. And this carbon dioxide capture is done by different methods. We can't go to the extent of it, but we have many methods like membrane separation, zeroite method, metal organic framework method, and chemisorption, physisorption, adsorption, absorption. There are different methods for this carbon dioxide capture. And we can see the screen.
Ma'am, it's a time reminder.
Yeah, yes. Clean flue gas, and then the carbon dioxide is trapped. Then we have the pre-combustion, where the fuel and air is converted into the syngas. Syngas in the sense carbon monoxide and hydrogen actually. That's converted to carbon dioxide and water. So carbon dioxide is again captured, and hydrogen is sent to the energy conversion, where it is sent to some renewable source of energy in the power generators. Then come to the oxygen combustion. Oxygen combustion is nothing but it is combusted in the oxygen or atmospheric air, opposite in the direction of the air, and produces both carbon dioxide as well as water and other trace impurities. The carbon dioxide that is captured consists of about 75 to 80% of this carbon dioxide is pure, and then the traces of water. After carbon dioxide is captured, it is again sent to the power generator. The other one is chemical looping combustion, where you have the oxidizer called as air reactor and a reducer called as fuel reactor. Here we use a metal oxide.
Ma'am, conclusion, please.
Yes, sir. Yes, ma'am. So metal oxide is responsible for converting this exhaust gas into carbon dioxide and water. So the carbon dioxide transport and utilization, we have different modes here, as we have seen the onshore and offshore capture of carbon dioxide, buffer storage, and the geological storage. So we have miles and miles of the pipelines, 225 kilometers. We have so many 800 kilometers pipeline, and we have seen this in the survey that in Texas and other places, they have already ventured into this, and these pipelines are carried offshore and onshore both. And in the geological storage method, they sunk deep pipes into the ocean beds 3 kilometers inside as well as in the soil. So what do they do is carbon dioxide slowly converts into methane, and methane can be used as a power fuel. Then the challenge is, we know almost 500 megawatt fossil fuel will be giving 8,000 tons per day, and that is a challenge for us to capture the to capture the carbon dioxide, design equipment so that the absorption technology and the diameter and length and height of these pipelines have to be scaled up. Then these CCS technology, that is carbon capture and storage technology, to reduce the emissions of carbon dioxide, still must be in a substantially more advanced method should be implemented, and the multiple hurdles are there which we can't sideline these things. And the robust economic incentives, we have to make it as a business and give it as an employment. Thank you. And these are the references.
Any questions you can ask, please. Okay. Thank you, Aparna madam.
Thank you, madam. Thank you so much.
Yeah. And the next participant, it's Uma Devi.
Good afternoon, ma'am.
Good afternoon, Uma Devi.
Audible, ma'am?
Yeah, you're audible, but are you sharing your presentation?
Okay, ma'am. Shall I start, ma'am?
First, you share your presentation so that we can all see, and then you start.
Okay, ma'am.
Yes, Uma Devi, you can go ahead.
Okay. Myself, Uma Devi. I'm a research scholar from Osmania University under the guidance of Professor M. Vichalata. My topic is molecular modeling and phase studies for identifying novel PI3K AKT mTOR inhibitors. The PI3K AKT mTOR signaling pathway is very important. Pathway is one of the most frequently activated signaling pathway in human cancer. Upon a growth factor stimulation activate the PI3K is converted to PIP2 to PIP3, which then AKT is recruited to the membrane by the interaction of this phosphoinositide docking site. So that it can be fully activated the AKT. The activated AKT mediate downstream regulation, including cell proliferation, cell survival and growth factors. The AKT introduction. The AKT, also known as protein kinase B, and act as an essential node in the PI3K AKT mTOR signaling pathway that promotes metabolism, proliferation, cell survival. AKT belongs to the AGC kinase family, and AKT also derived to the 3 isoforms, and AKT1, AKT2, AKT3. Among them, AKT1 is widely expressed in various tissues. The AKT has been found in large number of human cancers, including breast, ovarian, lung cancer. Therefore, the inhibition of AKT presents great potential in the treatment of cancer. The AKT consists of 3 conserved domains. One is the N-terminal plexistrine homology domain, and ATP binding kinase domain, and C-terminal domain. Then go to methodology. The X-ray crystal structure of protein was downloaded from the protein data bank. Protein required to protein preparation, minimization, and grid generation. After grid generation, done molecular docking. All the derivatives are ligand preparation using LigPrep. The in phase provide the 6 pharmacophore sites that are hydrophobic and aromatic and hydrogen bond hydrogen bond donor, acceptors, and cations, anions. The pharmacophore create sites and common pharmacophore. Find common pharmacophore, score hypothesis, generation of Qsr model. All these features need to match different chemical groups with similar properties. Then in order to identify a designing of a new molecules. The Qsr results for variant hypothesis generated third phase. Among these three, the AADRR got R square and Q square values. R square is 0.93, Q square is 0.67. The figure 3 is described 3D Qsr model visualization for the best active molecule. A is hydrogen bond donor, B is hydrophobic region. In figure A, green and blue cubes signify hydrogen bond donor and acceptor groups. In figure 3, green and orange cubes represent the hydrophobic flavored and discovered groups. The figure 4 is scatter plot for the experimental versus predicted PIC 50 values of training and test set compounds. The conclusion of this presentation, based on the figure 3, it gives a new pathway for designing a new molecule. When I changed R1, R2 groups, got different dot score values. The A14 is highest docking score, minus 12.489. The figure 5 is ligand interaction diagram of newly designed molecule A14 showing hydrogen bond interaction with threonine 211 and serine 205 and aspartic acid 53 and one pi stocking interaction with tryptophan 80. So thank you.
Any questions? Kavita ma'am?
Yeah, no ma'am.
Okay.
Nice presentation.
Thank you.
So, next participant.
It's Sunny Grace.
She is not there, I think. We can call Shravani.
Yeah, Shravani.
Good afternoon, ma'am.
Good afternoon, Shravani.
Shall I share the screen, ma'am?
Yes.
Good afternoon, Kavita, ma'am.
Good afternoon, Shravani.
I'm Shravani, working under the guidance of Dr. N. Navanita, ma'am, University College of Science, Hyderabad, OU. My research topic is synthesis, characterization, DNA binding, and molecular docking studies of ruthenium-2 polypyridyl complexes. Ruthenium-based complexes are known for their impact as drug candidates. They have little common with existing platinum-based drugs. These ruthenium complexes are having important properties in medical applications. The ligand exchange rate is fast in these complexes, and ruthenium is having accessible oxidation states, and it is having the ability to mimic iron in binding with various biological molecules. That's why we have selected ruthenium complex preparation. So the present study focuses on synthesis, characterization, DNA binding affinity of 3 ruthenium-2 polypyridyl complexes, where ruthenium A2-QPDA plus 2 complexes we prepared. A is ancillary ligands. First ligand 110 phenanthroline, second one TPZ, third one bipyridyl, 2,2 and bipyridine have taken. This is the methodology of synthesis of the ligand and metal complex. Synthesis of ligand. In this, phendione is added to the phenazine 2,3-diamine in the presence of gaseous acetic acid and ammonium acetate. The QPD ligand QPDA ligand was synthesized. Then synthesis of metal complex, mixture of this ruthenium, phenanthrene chloride and QPDA in ethanol was reflected for 10 hours under nitrogen atmosphere. Then the other two complexes also synthesized by using same procedure. Then all the three synthesized complexes were characterized by using IR, UV, NMR mass spectral studies. In IR, we got the stretching frequency value of NH appears at 3100 and the carbon nitrogen band appears at 1000 range. After complexation, these two bands were shifted. Then the ruthenium nitrogen stretching frequency after complex formation, it indicates at 600 nanometers. And UV visible spectral studies, the metal ligand charge transfer band appears at 400 range. So with this, we can confirm the complex formation. After characterization, UV visible absorption and the fluorescence emission viscosity studies performed to find the mode of binding of complexes with the DNA. In UV visible absorption studies, these studies performed at MLCT band range, that is 430 nanometers. Then to the complex, slowly increased addition of increased concentration of DNA is added. Then in the scattered plot, we observed hypochromatic shift. This shift is because of the interaction of ruthenium complexes through hydrogen bonding with the various functional group present on the edges of DNA. Because of this hypochromic shift, decrease in the absorption intensity observed. And with respect to graph intercept, we can find out the intrinsic binding constant. These were found in between 4.5, 3 and 1 into 10 power minus 4. Then we compared these values with already reported complex. We got less binding. But when we are comparing 1 to 3 complexes, the complex 1 phenanthrene complex is showing more binding compared to 2 and 3 because of its more planarity, and there is no steric hindrance over the ancillary ligand. Then we performed fluorescence emission.
Time reminder, please.
Fluorescence emission spectral studies at 520 to 670 nanometers. Then the emission intensity values increases slowly by the addition of ctDNA. This is because of the interaction of complex with the DNA. And relaxation in the vibrational energy increases the emission intensity. Then we performed quenching studies to know the mode of binding. In the absence of DNA, the emission quenching of the complexes is more with respect to the quenching agent potassium ferrocyanide. In the presence of DNA, because of its binding, intercalation binding mode, it cannot quench the complexes emission. Then we performed viscosity studies. Then because of the intercalation binding mode, when we are adding the DNA to the complex, then slowly viscosity of the solution increases. This is because of the DNA length increases because of the intercalation binding mode. In case of first compound, it is more because of its planarity. Molecular docking studies also performed to find out the mode of binding, and we got 193 complexes, more hydrogen interactions, hydrogen bonding interactions are there. In the second complex, we got van der Waals interactions. In AC values here, we got more for first compound. This is desolvation energy values. Desolvation energy is more, then binding is more. So with this, we can conclude that 1, 2, 3 complexes. In 1, 2, 3 complexes, first complex, phenanthrene complex, has higher binding capacity than second and third compound because of the availability of more planarity and no steric hindrance over the ancillary ligands. So then further we are doing my antimicrobial and anti-cancer activity for the synthesized compounds. Thank you.
Thank you, Shravani. Participants can ask questions. Kavita madam, any questions? Yeah.
Good, ma'am.
Avani?
Ma'am.
Any ruthenium drug is available currently in the market, and what is the competition of metal drugs in compared to normal drugs? What better qualities these metal drugs are having when compared to, because now we are having even for cancer, we are getting monoclonal antibodies and
Yes,
like we are having like monoclonal antibodies are very advanced. So is there any ruthenium drugs available in the market? That is my first question.
Ruthenium
second
complex
question is,
and anti-malarial drugs were there, ma'am. Ruthenium drugs, chloroquine drugs, and it is acting against malaria, and same derivatives of thiazolidine.
How good? It's efficiency.
Ma'am?
It's efficiency when compared to other drugs.
It can bind with the DNA strands more efficient than because of the structure and properties, ma'am. Electrostatic interaction properties. They can
I'm not talking about the interactions and all. We know the interactions and all. My question is, what is the comparative, like in the drug, like market? I'm talking about the market, drug market.
Oh, maybe they have other moieties may have a maximum toxicity is high, madam. For
because the binding which you are showing is very less.
Sorry, ma'am.
So, like I'm talking about the applicability of these studies.
When we compared these complexes with other complexes, existing drugs, that is, these drugs are having low toxicity, ma'am, when we compare it with platinum and other metal.
Okay. Thank you.
My knowledge, I think, madam, this ruthenium complexes for this as anti-cancer drugs, they have good selectivity, but the activity is very poor.
Yes, ma'am. It is having appreciable selectivity for tumors, ma'am, and maybe it is having low toxicity compared to other drugs.
Activity is very less, not considered practically. It is not applicable.
Yeah, that's my question.
Hello, ma'am.
That is the answer I want. Practical applicability.
Practical applications. We'll find out, ma'am. I will find out, ma'am.
Okay, Shravani. No problem. Nice presentation, Shravani.
Thank you, ma'am.
Thank you, Shravani.
Okay.
We will go to the next participant, and the next participant is Dilshad Raihana.
Hello, ma'am.
Yeah, you can share the presentation. We can able to see the screen.
Ma'am, can you able to see my screen?
Yes, we can.
Yes.
Yeah. Thank you, ma'am. I'm Dilshad Raihana from Chemistry Department of Manon Maniam Sundara University. I'm here going to tell about this investigation on benzothiazole imidazole derived shift base using DFT studies. Here is my outline, and here is what density functional theory. It is a quantum mechanical modeling method which is widely used now in physics, chemistry, and material science departments in order to investigate the electronic structure of many body systems. Why DFT is mostly used, it is because of we can solve approximately most probably the Schrödinger equation for in-body systems, and it doesn't require supercomputers for that much, and it is cost effective and reasonable time. Shift bases are usually the products of aliphatic or aromatic amine group, which is condensed with the carbonyl or aldehyde group with or without the catalyst, and it is gaining more and more importance by present scenario. Shift bases are mostly used in biological applications such as anti-tumor, antibacterial, and anti-tuberculosis, etc., as well as in DSSAs. It is a synthetic method for synthesizing, and particularly in DFT studies, the first step we have to do is optimization, and here the optimization is done by B3LYP 631G
decomp basis set. It is calculated in gaseous form, and the DFT and the total energy is calculated by the stretching, bending, torsional, and non-bonding energies. And here we have the UV visible spectrum with us and the IR spectrum. Here it shows in the visible spectrum with the pi to pi star transition with the excited state of 366 nanometer and 347 nanometer as calculated, and the vibrational spectra shows its image stretching, and mainly it shows the shift-based stretching at 1682 centimeter inverse, and the NO stretching along with its aromatic stretchings, and the CS stretching is also present here, and the C13 NMR spectra, and the carbon which is present at the center of C7, at the center of nitrogen is C7, which is presented in 186 ppm shift, and the doublet shift which is for C1 and C17 carbon, and the C17 carbon which confirms the shift-based formation, and the singlet signal for fourth carbon, and the triplet signal for C18, C22, and C7. C1 carbon, and the 19th carbon which is for a singlet signal, and the three triplet which is occur for the C5, C6 and C3 carbon, and the hydrogen NMR which is also calculated using this tetramethylsilane as a reference, and which is calculated using this famous method, and the hydrogen which is attached with the nitrogen which is having the chemical shift at 9 p.m. and then the chemical shift for shift base hydrogen is confirmed at 8.6, and then for the hydrogen which is at 9 and the chain which shows next to it, and then the 20th hydrogen and the 26th hydrogen which is shows next to the shift. And we have analyzed this frontier molecular orbital analysis, and here we have the HOMO-LUMO orbitals with the molecule with the band gap of -0.35, and this band gap is actually greater, which is for less reactivity, and it will have the more conductivity and low kinetic stability, and termed as a hard molecule, which represents the intermolecular charge transfer within the molecule, and the molecular electrostatic potential. It is an effortless interpretation using this system, and the sulfur and nitrogen are electron-rich centers which are prone to nucleophilic reactivity, and the hydrogen which is an electron-deficient region prone to electrophilic reactivity. And we have
Dilshad, it's a time reminder, please.
It's we have a similar molecular docking, and it is having good molecular binding energy. 7.4 and 7.6, and it is having a good hydrogen bonding with the molecule that makes the molecule more favorable for the biological interaction. And here we have a conclusions. In this we have investigated this material using Gaussian software, and we have optimized the molecular structure, analyzed the electronic vibrational NMR spectra theoretically, and performed HOMO-LUMO, MEP, and the molecular docking. Thank you.
Thank you, Dilshad. You have bound to 8 slides, but you are very fast in explanation, I guess. And I don't know what's the problem, but it's open for questions. Kavita ma'am or any participants?
Yeah, no questions from me.
Yeah, okay, ma'am. Any participants, any questions? Okay, thank you, Dilshad.
Thank you.
You have done a very nice work actually, but you are very fast, and
I'm actually limited to this time limit. I'm scared that whether I can't complete that. That's what I'm.
Yeah. Actually, you could have concentrated more on your analysis part. So
yes,
okay,
ma'am.
that's nice, Dilshad. All the best.
Thank you, ma'am. Yeah. Thank you so much.
The next participant, Hajera Sana. Is oral presentation number 31. Anyone there?
Dr. Sushma.
Yeah, are you presenting, Sushma? She opened her video, but she is not. Dr. Sushma, are you?
Sushma, madam, are you there? Madam. Maybe she is having technical problem.
Okay, ma'am. And Dilshad, can you please close the presentation? Can you please stop sharing?
Yes, ma'am. Yes,
yeah.
ma'am.
Yeah. And probably that might be the issue, ma'am. Yeah, right. Sushma, madam, you are there. Please unmute yourself. Yeah.
Am I audible?
Yeah, ma'am, you are audible and your presentation is also visible. Yeah, ma'am. Okay. Go ahead. Yeah.
Yeah. Good evening, one and all. I am Dr. Hajra Sana from Department of Botany, Koti, Women's College, Osmania University College for Women, Koti, and I deem it my pleasant privilege to present on the topic for today, that is mycodiesel, an alternative and new approach for biofuel. So, as we all know that nowadays the biofuel, like there is a diminishing supply of fossil fuel reserves, and the environmental concerns that have made us to focus on renewable sources of energy. So nowadays, green chemicals and biofuels are gaining importance as an alternative resources for the production of fuels. So similarly, there is an important fungus, endophytic fungus, which is found to produce some volatile organic compounds which can be dubbed as mycodiesel. The fungus is Glocladium roseum. So it is found to produce some chemicals which are resembling the diesel. So it has, this is the Glocladium roseum, which is the producer of mycodiesel. You can see this Glocladium colony on medium, and it is a filamentous fungi. So let me introduce about the fungus to you. So it is it belongs to Bionectariaceae family, and it is an endophytic fungus. It can be found on the soil. It is present in the soil, and it is used as a biocontrol pest agent. Okay, it feeds on nematodes, and it can also inhibit the growth of other fungi. So it is used as a biocontrol agent. So it is so coming to the chemical composition, Glocladium roseum is known to produce some hydrocarbons which can act as mycodiesel, and it has produced a series of acetic acid esters of straight changed alkanes like pentyl, hexyl, heptyl, octyl, and decyl alcohols, and some other hydrocarbons also, when grown on oatmeal-based agar medium. So when it is grown on oatmeal-based agar medium, it is known to produce some chemicals which on SPME, GS, MS analysis, they have shown to produce the chemicals which are resembling the chemicals present in the biodiesel. So through this, we can conclude that the volatile compounds that are being produced by Glocladium roseum are known to be associated with petroleum diesel, and hence these volatile compounds, they can be dubbed as mycodiesel, and this fungal strain could be developed into an industrially potent strain for the production of biofuel, and the commercial scale up and feasibility of this approach will be helpful in solving the world's need for the liquid fuels, which is the need of the hour, as we are facing a threat of petrol, and there is a diminishing diesel these days. So why not go for mycodiesel? So this is a very excellent fungus which is providing us mycodiesel. The research is still in its infancy, but one day we'll reach to a commercial scale also, I hope. And I would like to acknowledge Vijulata ma'am, our principal ma'am, for giving me this opportunity to showcase my work. And I'm extremely grateful to Dr. P.R. Sushma for her constant guidance. And I'm also thankful to Dr. Mehtab Yasmin ma'am for being a very good companion in the source of learning. And thank you one and all for your patient listening.
Thank you, ma'am. You are very time bound. Actually, you have finished your presentation within 4 minutes.
Thank you, ma'am.
So, yeah, Kavita, ma'am, questions, you can ask questions.
Yeah, Hazira.
Yes, ma'am.
Did you do the experiment and you have collected
Presently,
this information?
we have just isolated Glaucladium roseum from our college. So we have the Glaucladium roseum as we have stored it, and we are in the process of doing the analysis also. So we have reviewed it actually, and we have just isolated it from our campus.
But this is a literature information, right? Whatever
Yes,
you have presented.
Yes, ma'am. This is a literature information.
Okay. Okay. Thank you.
Thank you, ma'am.
Thank you, ma'am. It's a nice idea, and hope we will get back. We'll be producing this in a large content in future.
Definitely, ma'am.
Yeah, definitely. Yeah. The last participant is a Hari Babu. Is he there?
He's not there, Yamini.
Okay. Ma'am, if the last participant, oral presentation number 32 is not there, if that is the case and we have finished with all the participants, ma'am, Kavita madam. Haja ma'am, can you please mute yourself?
Yeah, sure, ma'am. Sure.
Kavita ma'am, we have finished our number of participants in oral presentation. And it's really very thank you so much for patiently listening for almost for 2 hours. And thank you all participants for participating in today's international conference. And ma'am, any suggestions? Kavita,
yeah, I thank all the participants. Everyone presented very well, and most of you were time bound also, because giving a presentation in 5 minutes is going to be a very tough job when we have lots and lots of results. I know that is a big task which you have achieved today. And one more thing, all the works are really good and very nice ideas. And I congratulate all of you for presenting successfully. And I thank you all. But whenever you have this type of time-bound presentations, it's always better. You concentrate more on your results and discussions and more on spectra. And also, you better be prepared with the, if you are presenting any drug molecule or any antibacterial studies or any such things like that, better you compare with the current drugs which are available in the market. That's my suggestion. And thank you so much for giving me this opportunity, the organizers. Thank you all. Thank you.
Yeah, once again, Yamini madam. Yeah, thank you very much, madam, Kavita madam, for your valuable suggestions, and out of your very busy, tight schedule, you have taken time for us. And yeah, thank you so much, ma'am.
Shashikala madam, anta formality oddu.
Ledu. I know that situation. So that is, yeah, I'm saying.
Thank you, ma'am. Thank you, Kavita ma'am, for being with us today as evaluator. Thank you so much for your kind time, ma'am.
Thank you, Vijayalakshmi ma'am.
Thank you, ma'am. Thank you once again.
Yeah. Okay. Madam.
Madam, a small query. I have not sent the paper for publication because I wanted to have it published. I was waiting for the plagiarism check, madam. So do I have time?
Yes, ma'am. You can send. We are looking into that after the conference. We will send whoever are sending registered for the full paper thing. We will send to all of them.
Okay.
Yeah, you can send, ma'am. So you need to get the plagiarism check, and after that you need to send.
That's what I was waiting for, the plagiarism check. Within 1 or 2 days, can I do it?
Yes, ma'am. Please.
So I should send it to the head of the department.
Yes.
Yeah. Thank you. Thanks a lot.
Okay. Thank you. Yes, I think Yamini madam.
Yes, ma'am.
We have completed the session.
Yeah.
Right. Yeah. Shall we close this?
Yes, ma'am. Thank you all the participants and Revati madam for supporting me and in conducting this. Shashikala madam, thank you for supporting, being there as a support for us. And thank you all participants for giving such a nice oral presentation. Thank you for giving me the opportunity,
really
ma'am.
very nice presentation. Good work we have seen. So very nice. Wish you all the best. Thank you all.
Thank you, ma'am. Thank you for the opportunity.
Okay, thank you all.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you.